Hallo zusammen, es ist ungefähr 10 Uhr morgens in Redmond. Also, es ist Zeit für jedermanns Liebling-Internet-TV-Show mit Argumenteten? Ja. .NET API Review. Cool. Even used a script and still failed. For some reason, Google Translate didn't like throwing the word argumentative in between internet and TV show. Who knew? All right, today we are talking about generic math, which means that in 2 hours, if you're still paying attention to the whole thing, your brain will have leaked out of your ears. I'm looking forward to this sensation. Yeah, so cool. Tanner, shall we get started?
Yep. Uh, the first thing related to generic math we are going to want to review here is two things related to C# and some decisions it's going to make. The simpler one we can probably do first, which is just uh, as part of generic math, C# 11 is going to be adding support for user-defined checked operators. These will require new IL names to support those operators so that they're standardized across the ecosystem. Uh, in IL today, operator plus for addition is just called op_addition. The proposed names here are correspondingly op_checked star, where star is the rest of the name. So checked becomes a prefix on whichever operator you're providing a checked variant of. And so the proposal is just we officially add and document that we have op checked increment, decrement, unary negation, addition, subtraction, multiply, division, and then op checked explicit. There is no op checked implicit because implicit conversions should never overflow.
I know that we have that as a design goal, but from a purity perspective, would it make sense for the runtime to allow it, or is that just being stupid?
We don't expose. I don't think it's worth exposing operators for something which is not a best practice and which C#'s not going to support. If we ever decide the language or some other language should support in the future, we could add it then. And then to address Imo's question on on prefix versus suffix, we currently use a prefix for other things. For example, left shift and unsigned right shift, rather than shift right unsigned or shift right. So the prefixing is currently the convention for other IL names, which is why the proposal does that as well.
Seems legit to me. Any objections?
One dumb question I have is how do you opt into the checked increment operator? Or is that like a language thing that we'll talk about in a different place?
It's a language feature where if you are in a checked context, the language will decide to call it. And any language on how it exposes those operators may differ. F#, for example, has a concept of opening a particular module that gives access to the checked operations, and so it would likely differ in how it exposes it from C#.
And then when I write the operators,
right, that would be a language specific thing, based on how the language decides to support those operations. This is just standardizing the backing API contract for those operators. And then how any particular language decides to support it is up to the language.
makes sense.
So just to confirm, like we're retconning the existing user-defined operators to say like thou shalt be unchecked?
The language is the current language design has it so that both checked and unchecked operators must be provided, so that you are allowed to provide one operator as you do today, but if you provide a checked operator, then you must also provide the unchecked equivalent, which would be just op_addition.
Okay, so I guess that also implies that if I don't opt into this system as a type developer, then any types that I develop with custom operators, I would have been expected for those operators to have been unchecked.
It's not necessarily that it's unchecked, it's that it's the current behavior. A given operator is free to if you're only providing a single one, then a given type can decide whether checked or unchecked is the correct default, just as they could today. So there's no change from today if you're only exposing one operator. You can make that checked or unchecked, and that's the global behavior for that. If you are exposing an additional checked operator, the expectation is that you will provide both, and that checked will overflow and the other will not.
The other way around.
More by overflow, you mean throw an overflow exception?
Sorry, it's the other way around. The checked would throw, and the other one would overflow.
Right.
And I guess what I'm trying to figure out is if someone had an operator where their operator plus, for instance, was as an implementation detail checked, and then they wanted to take advantage of this new system and say, oh, let me create an actual like checked API, would they have to change the implementation of their existing operator, and would that break existing consumers when they release a new version of their package?
Yes, and potentially.
Okay.
So, for example, if DateTime wanted to support overflow checking, it could go and add an op checked, and now in checked context on recompile, users may start seeing exceptions where they did not previously if they were doing DateTime operations in a check context. And so there's a breaking change consideration when adding a checked operator where there was not previously.
So I was actually saying the opposite.
Right, and in the opposite case, where you have the regular one throwing by default, you would have a behavioral change where existing compiled code would now not overflow where they did before.
As long as like this is a behavior that everyone's agreed upon, I'm fine. I just wanted to make sure that was written down somewhere.
We can send a link for the C# spec.
I mean, the user is free to do whatever they want. I mean, it's up to them how they implement the operators. The language provides, C# language provides how it would be using them, right? And it's up to you essentially. Language doesn't really prescribe you what you have to do with your operator in such and such situation. So obviously, changing behavior of any existing API is somewhat breaking change into either direction.
Well, that's the problem, right? Like the language previously, as you just said, did not prescribe a behavior, and now we're saying the language, in fact, does prescribe a behavior if you opt into the system. And as an in-place update, that behavior might be a breaking change.
Prescribes the behavior for checked operators, and there are no checked operators today in the system. Right, so if you want to play nice, sort of, you probably might need to change the behavior of the other operator, but that's the consideration you need to take into account. Like anyway, regardless, that's an existing API. It already has legacy behavior. So yes, you have to make the considerations what to do about that. So I don't really think that there is something new here. I mean, obviously people need to understand, perhaps, but
if you had, like, adding a new checked operator because you were already doing unchecked operations inside your operator is only breaking for the people who opted into checked, which is what they wanted, probably. Otherwise, if you have a currently checked one, making a separate checked operator is a breaking change that you need to evaluate to your own breaking change tolerances. But I don't think that really impacts the name or the design here, so I think we can move on.
Is there any other feedback on this one? I'll take that as a no. And then, so moving to the next one, which we don't have an issue for, it's more of a meta concept. And I'm just going to copy and paste this here. That way it's easier to see. So in .NET 5 and C# 9, the language introduced the init keyword. Alexei?
Could you bump the font more, please?
Is that better?
Yeah, that's better. Thank you.
Okay, so in C# 9, the init keyword was introduced, which allowed the system.IntPointer type to get operator support. However, due to various back compat concerns, among other things, IntPointer was kept as a different type. With the introduction of generic math, we've got a number of new APIs that need to be exposed on system.IntPointer, which, given the current design, only makes sense on int, the language keyword. However, there are a number of complications that come out from this, and so there was a discussion between C# and LDM, or between C# LDM and API review last week, which basically came down to two proposals. One, we take a breaking change. We make, in C# moving forward, we'll treat init and IntPointer as true aliases of each other, in the same way that int32 and int are aliases of each other. Or B, C# effectively freezes the API surface of system.IntPointer at its level. And so any new APIs exposed on IntPointer would be inint exclusive moving forward. Effectively, the source code would be free to expose, the BCL source code would be free to expose anything, and they would never appear on IntPointer. IntPointer would likewise not be usable in any kind of generic constraint, such as where t is inumber, but inint would. There was a fairly split vote between these two options, with a slight leaning towards the preference of taking the breaking change, provided that C# could limit the scope of that breaking change. Jared, Alexei, Julian, and Chuck met and to discuss this, and the proposal there was that .NET 7 would add a runtime feature flag indicating that IntPointer and init should be merged. When C# sees this flag, it will create the init symbol. It will effectively treat them as true aliases. This will limit all compat breaks to the target framework .NET 7 or later. However, if you are targeting a down-level language version, so for example, you are targeting .NET 7, but also targeting C# 8 or C# 9, you will still get the break. So there is a language break there that is tied to the framework version. Jared?
Yeah, and I was just going to emphasize something I kind of wrote there at the bottom. It's like, that is likely to be a somewhat minimal break, because it really only happens when you push the target framework up and then push the language version down. Generally, what we see is the opposite. If people custom specify language version, it's usually to push the language version up. It would be like people who are targeting, say, for instance, like .NET Standard or .NET 5 and pushing Langver up to 10 or preview. In practice, the most common the most common value for Lang version that we hit is preview. So that would not hit this particular intersection. So I have some confidence that the intersection of people who would do that would be pretty low. And also, Langver is not a guarantee. Langver is just a very accurate heuristic. It's a guardrail to keep people on the right path. So violating, not having features and behaviors that change and don't get flagged in Langver, it's not the end of the world. It's something that we strive hard to not do, but they're guardrails. They're not absolutes. So, but overall, we do feel confident that we could implement this change in the compiler efficiently and without having to revisit a lot of kind of performance decisions we've made on sharing. So we think that if we want unification, this is the best approach we feel.
There's no way somebody can use an older compiler and target net 7, right?
No, that's not. So can they do it? Yes. Is that supported? No. The language and the SDK do not support that configuration. Like, one thing that we explicitly have as a part of language design and compiler design is like a C#9 compiler cannot see the output of a C#10 compiler when you are targeting like .NET 7, when you have the like keyfs in the right directions. So it's basically, I should say a little bit differently. The output of compiling with like Langver 10 cannot be seen by a compiler that could at most target Langver 9 because the target frameworks and SDKs don't line up. We don't consider that a supported option. Yes, if you hack the tool sets and you do a lot of evil things, you could see that, but fundamentally that's not how the SDK works. The SDK does not allow you to take a .NET 7, a library compiled for .NET 7 and use it in .NET 6. And the associated language versions follow that pattern for that reason.
I mean, it makes sense. So we are backwards compatible, but not forwards compatible. So that's...
Yeah, and that's just how it has to work. Otherwise, we'd be really put into a lot of corners if we couldn't like update metadata and things like that.
So that means effectively there's no if lang version in the compiler with respect to this behavior, but it's purely based on the presence of this field.
Yep. Which I think for the most part is not going to be, like, honestly, like the material impact of that is there's kind of two material impacts of that. It means that when you move up to essentially when you move to .NET 7, I guess 3 material impacts. There will be a couple more APIs on nint, like .0, but that's really not a back-compat breaking change. You couldn't have referenced them in .NET 6. It's possible that there would be subtle changes to overload resolution or how conversions wind out because the types would be unified at that point, and we don't have to worry about some logic in terms of like which conversions are preferred over the others. Those would be super, super subtle. I mean, I'm sure 1 or 2 people will notice, but it's not. That's something that we would like making subtle changes to overload and things like that is something we don't categorize in Langver anyway. The biggest change is going to be that when people upgrade from 6 to 7, that their IntPtr math is suddenly checked if it was in a checked context. And we've already discussed the idea that the generally speaking, that for this overall change, the runtime should consider adding an analyzer that says, if you are doing one of the 6 operators on IntPtr, so the conversion operators, the plus and minus operator, and maybe one more I'm forgetting that Tanner will remember, if you're doing them and the type is explicitly IntPtr and it's in a checked context, we should consider just warning people and saying, this is probably not doing what you expect it to do anymore. And users can adapt to that in one of 2 ways. First way is, say, if you're like, oh, I love the checked math here. This is what I always wanted in my life. You change that from IntPtr to nint and move on with your life. You just switch the type around. If you're like, no, I did not want that behavior, this is undesirable, fantastic. Put an unchecked block around the math. In both cases, the analyzer stops triggering, and it's a very high, like it's a very targeted analyzer that has very declarative fixes. And I think that is the biggest kind of, I think, trap that users can fall into, and I think an analyzer is very targeted at fixing that.
Clarification, Jared. An analyzer would see that you're in a checked context because of the checked compiler switch, right? Because it's part of the compiler.
Oh god, it's so much harder than that. There can be checked blocks.
No. I understand checked blocks and checked method declarations and whatnot. Those are obvious that the analyzer can see. So the non-obvious one is when checked came from a compile flag.
Yeah, but that's in the options, and it's very visible.
Okay, so we can make an option. We can make an analyzer that would work for everyone, assuming that somebody actually does check that button. Yes, check that button. I can speak words.
Looks like Alexei or Julian has a comment. They've got their hand raised.
Alexei, so the analyzer can check the symbol that has been used, and based on for the operator or for conversion, and based on that, essentially, the analyzer can sort of figure out that this is a checked operator. So it doesn't really need to track the nesting of checked blocks or checked expressions. Like, for example, if the goal, however, there is a wrinkle around the fix that I just realized. An int and int pointer will be indistinguishable. So I don't think that the fix, the proposed fix, like switch to the an int, would make any difference unless the analyzer would somehow look at usage of an int syntactically, because from the bound information, those two types will be absolutely indistinguishable. That's the point of basically unifying them. It's the same as if you type int or system.int32 in source, if you look at what's the bound type of both of those, it's the same type. Basically, you cannot, from bound information, essentially from the type symbol, you cannot make a difference what was typed in the source.
Yeah, I completely agree with that. My expectation was that they would have to do a syntax check, essentially, that they would have to do that. And I understand that there are some complications. We have to kind of get over that with aliasing and stuff, but I think it's more work, but it's solvable, I believe, right?
Right. I just wanted to kind of make the situation clear rather than sort of facing this problem when someone starts implementing the analyzer.
Makes full sense.
And I can't see the participants list while hosting the stream, so whoever had their hand up before emo.
Eric Earhart's next.
Okay.
So my question is, why didn't we do this in the first place? Like, why didn't we have an int and pointer be same?
There was pushback by various LDM members not LDM, API review members at the time that believed that int pointer and inint should be distinct because they represented different concepts.
But I appear to be losing.
There was not an overwhelming majority on either side. It was fairly split, and there weren't enough people willing to fight for one of the sides over the other. There were also some concerns around the cost of the break, but some of the long-term complications, the recommendations we're making around how people handle interop moving forward. People shouldn't. We explicitly tell people they shouldn't use int pointer to represent handles. They should be using safe handle and other types for that. It all points towards actually, it starts pushing the dial over towards we really should have made these two consistent in the first place.
So the original concern was they're two different usages, so that's why they should be two different types, or two distinct types. I guess there's probably not a better word here.
It's hard to describe them because they're not really different types. And languages like F# have always supported them as the same type since V1 of their language. It was really just .NET Framework added some APIs specifically to support its use as a pointer-like type in .NET 4.0. And when C# added the keyword to help handle the user request that had been building up for many years, it ended up leading towards um, some people arguing that that system.IntPtr, the full type name, should continue to mean I am a pointer-like or handle-like type, and inint should be I am a native integer-like type. And the overall view, along with generic math, the changes that we need, and the fact that C# is going to have to deal with this in one way or another, led to the discussion of how are we going to deal with this, with one of the options being, let's just go ahead and take the break, fix this moving forward.
You are gonna have operators on int pointer that just don't make sense, right? Like dividing two int pointers. That doesn't.
But I mean, one thing is like all the primitive types have those operators if you look at them. And what we're doing is, I agree, it kind of like, in some ways you look at it, it makes no sense. You're like, why do you have those operators? Because we're just going to emit the opcodes anyway. But this is just like, I don't have an intuition on why it was done this way, but it was done this way. By putting all this decision, like, puts us in a place where you end up putting all the operators in IntPtr. The compiler treats it like nint, when we do the same special casing with the operators in IntPtr that we do with the other primitive types. And so some of the conventions might seem a little weird, but what it's doing is basically kind of acknowledging that IntPtr is our native int type. It's putting it on all the same level playing field with the other ones going forward. So we're trying to essentially do the same conventions that we have on other types, more or less.
And division only doesn't make sense on IntPtr if you consider IntPtr only a pointer type. And even then, that's kind of hand wavy because people use division with pointers all the time for doing aligning and masking checks and things like that. The guidance that we tell people is, if you're working with pointers, use pointers. Don't use IntPtr. If you're working with integers, then use, inint IntPtr. And then it becomes, just like with int32 int, which one you use is your preference. And you probably should prefer the keyword for all the reasons Jared's written down in his blog posts before.
Okay, this is just like doubling down on this keyword means this type.
Yeah.
Okay.
It will likely also provide some perf throughout the BCL where we're still using IntPtr, and where we've explicitly had to use hacks and workarounds to use inint to get better code gen. There's a lot of places where we take IntPtr for legacy reasons. We've not been able to change it to inint for legacy reasons because they were distinct types, and merging them and actually considering them the same will allow us to fix that and allow the code gen to just be improved. So we no longer have to insert fake cast to inint to get the right small IL.
So my question was, is there no scenario where we want this behavior on some library that targets net standard 2?
I would say that there is potentially the scenario that you're like, okay, I'm targeting net standard 2 and I want the new operators. And there's a very easy solution to that. Use nint. If you use nint, we will do the right thing in all the circumstances. There are, I'm sure if you really got down to it, you would find some differences, like some of the APIs that Tanner that will be kind of exposed in .NET 7, like .0, .subtract, and .add because of the type unification. Some of those would not be available if you down targeted to net standard 2. But overall, like nint will work just fine if you down target to net standard 2. It will do by large and far what you expect it to do and what it would do in .NET 7. And that's the general answer. If you're like, well, I want to target .NET Standard 2 and I want to use IntPtr, but I want to do checked math on it, then we're like, congratulations, you are a .NET 7 customer, not a .NET Standard 2 customer. But that's the kind of the trade-off here. I mean, most of this is not about changing how nint works. It's about rationalizing where IntPtr exists in kind of the hierarchy of our of everything, and how we safely combine the types without inadvertently hurting customers who like took dependencies on like unchecked math and things like that.
So is this something that is a general pattern moving forward, that if you want to do behavior changes in the compiler, that we would consider using the runtime features type for that?
God, no, please don't have us create parallel types and then merge them again later. Like this is not a general pattern. This is a slap on the hand that we are giving you all, and this is the out. Please don't have us do this again. When we got the request, I was like, wait, is this a joke? Do they really want to do that? Like, we did all this work to make it work the other way. It's like, in some ways, yes. Like, runtime flags continue to be a way for us to really say, like, okay, this is a new .NET thing. We can make very early decisions on like how, like, one of the biggest problems we had here that Alexei was kind of detailing for us, it's how we import symbols is very key to how like native int works and how we create them and share them. And like what the feature flag helped us with is like at the very moment we're importing, we can be like, oh, this is .NET 7, like do it this way. Like we can, at the very lowest levels in our code, we can make a very smart decision, well, a very informed decision on how this works. So runtime feature flags continue to help us in that area, but it is still not something that we want to add more of.
And in particular, there are no other built-in primitives that C# doesn't support. So we shouldn't hit this in the future. And for types which the library are adding that the language could add keyword support in the future, like half, or if we add int 128 and uint 128, we've had the discussion with the C# team on what the breaks would be if they were to exist. And we've accepted those minimal things as worthwhile. For example, with half, we understand that there will be some changes in how conversions work because built-in conversion operators work slightly differently from user-defined conversions. And literal support and constant folding support would cause some new syntax to work. And we all decided that was an acceptable cost for being able to expose half without C# adding simultaneous support, even if they decide to add that support in the future. And then for int 128 and uint 128, they were only blocked because we couldn't define user-defined checked operators. With user-defined checked operators, we should be able to expose it in the same way as half. And with the complete allowance for C# to expose support in the future without it being a major breaking change. I don't see any other hands, and I've not heard any significant pushback, just questions about various design points here, so it sounds like it's generally approved.
So I think we talked briefly about the analyzer, right? So that we see this part of this in order to make people aware of it.
I believe so, and I believe Jeff in particular had requested that in the email thread. I believe it would be up to Jeff and I to coordinate on how that gets scheduled alongside the generic math work and with the relevant folks who are already working on analyzers for .NET 7. Is that right, Jeff?
Yeah. Mads was wanting to see the analyzer as well, but yeah, what you just described there matches my expectation. I think we would probably land this change, probably a preview or two before we land the analyzer. But we can get the analyzer out by preview 7 RC1.
And the analyzer, like I think we talked about checked versus unchecked, right? But is that the only thing that it covers, or would it also cover the typical now you're calling operators on nint that you didn't before?
So So for int pointer, there's only a very limited subset of operations, and an even smaller subset of those operations which have differing behavior between itself and inint. And those are the conversions and addition and subtraction. Addition and subtraction are unchecked today, so if you call them in a check context, you may overflow where you didn't before. For the conversions, the behavior of them differs between 32-bit and 64-bit because int pointer is variable sized. And so on 32-bit system, if you are doing a long to int pointer conversion, that will overflow by default today, and it will not overflow by default when you switch to inint, assuming you are not in a checked context. For 64-bit, there is no overflow possibility, and so there's going to be no behavior change there. And likewise for the inverse, if you're doing int pointer to int conversion, you have an overflow case that can happen on 64-bit but not on 32-bit. And so the cases are very well understood. The analyzer should be able to flag those cases. Providing a fix for them may be complicated, as Jared explained to me over email, because there are various nuances in, for example, plus equals expressions and similar, where it's not as simple as just wrapping the individual part in a checked paren or unchecked paren.
Yeah, I think honestly, I think for the most part, it's like offering do we want to offer the fixers? Like I think the one fixture you can offer, which is very simple, is upgrade to native int. It's nice and simple to get rid of it. But the other one, like, I think it gets more complicated, and I would question if it's worth the investment. Like, because like the code fixer of moving the declaration from int pointer to nint is very straightforward. You already have to find the syntax, as Alexei pointed out, to understand which if you want to hit that. Flipping that word to another word is very easy. Trying to move operations from checked to unchecked in a way that preserves side effects gets the devil's in the detail very, very fast. And I would question if it's worth the investment to do that, and more tell people, like, you need to put this in unchecked context and let them make the decision on how to do it.
So aside from just, dropping in for the record, my original desire had been that they were two completely separate types and not managed as separate types in the compiler. I do appreciate the notion that we're unifying C# and F# with respect to this, but I'm going to say the dirty word now. VB? What does VB do with inint? Does it have it? Is this going to break VB in weird ways that we don't think about?
It's not going to break VB. So the reason why we didn't do this work initially is most of the rationale for adding this support into C# was about high perf leverage scenarios. The framework in particular, like, you could go and find places in Mono, you could find places in the .NET runtime where we essentially said using nint equals system int pointer, because we wanted the native word, having native word allowed some clever cogent optimizations in a number of places, and we wanted to use that. So as a part of that, we didn't add it to VB because the scenario wasn't there, so it wasn't worth the investment to add into the language. This change here of moving all of the operators onto IntPtr is not going to immediately change VB because it doesn't recognize them. And you couldn't be doing divide on inputters today in VB, so you can't do them tomorrow either. You couldn't do them yesterday, so it's not going to be an upgrade issue. If the desire for supporting the checked and stuff like that does come in, then we will make the change in VB.
Okay, so F# had them as already unified aliasing, C# had the complicated split, and VB only had IntPtr.
Right.
Okay.
VB is essentially where C# was at 8. We added nint in C# 9, so VB is effectively where C# was at C# 8. Now I don't think we have fully closed on what we're going to do with respect to recognizing or not recognizing the checked operators in VB, but it's, I think the intersection of people who are doing IntPtr math and checked and VB, like I'm not sure how big that's going to be. It's something we can consider if we want to write the analyzer to work for that too. But my suspicion is that would be smaller. But
Fair enough.
It's just intuition. It's not based on data.
Once we were talking in analyzer terms and having to reach over to the syntax node, it made me realize that when you do that, you break VB or you break your ability to have the unified code for C# and VB analyzer, and it's like, oh, VB is a question that I haven't heard asked yet.
Yeah.
So
I don't think the syntax checks would be that much harder there. The check for the syntax will be, I imagine, pretty straightforward. There's just one or two little hitches we have to think about. And I say, once you guys start writing the analyzer, grab someone from us. Julian is most likely working on this feature, so Julian would be a good person to talk to, and he can help you make sure you get the little checks correct.
all right, as the leader of the party behind Plan 1, I hereby concede and say that Plan 2 sounds like it's not going to break enough people to be bad. So
Silently break them. It will not silently break them.
it will not be enough of a very difficult to diagnose break that it's
Break is so judgmental. It's like we're improving people's lives. They just don't know it yet.
Will be.
It sounds a little bit too much like he only hits you because he loves you, but
That's basically what compilers do.
all right. So I think
There's not going to be anywhere to put a proposal stamp on this. It was mostly C# needs to get an official decision. That way they can move forward.
Yeah.
I will coordinate with Jared on making sure we get a proposal for the feature flag and marking that blocking, but that can just be done pretty trivially in a future review. It will be a 5-second. The name doesn't look incredibly bad, so approved probably.
So one last question, so in this proposal, basically, IntPtr and nint are completely identical, right? So I could define operators involving IntPtr or nint, and it's just the same as int32 versus int entirely. There's no more. In this particular case.
Yeah, if you're using the net core TFM.
Yeah, of course.
Yeah, the way to think about native int today is more or less the native int AP, the kind of symbol we create in the compiler for native int looks at the types on IntPtr and filters some out, and then adds a bunch of operators. And what we're saying is, it's kind of like remove some APIs and then add all of the operators we need for like things. In .NET 7 going forward, what we're saying is we will just take everything from IntPtr. There is no more subsetting and adding. It's just like IntPtr is now sufficient to stand on its own. Native int and IntPtr will literally do the exact same thing. It is no different than the relationship between system int32 and int. It is the exact same relationship at that point.
It's basically a code style thing more than anything now.
It's a code style, but because you all will likely attach an analyzer to IntPtr, it will be semantic because you are guarding against the silent check behavior. So I would say, in the same way that we tell people, like, please stop writing int32 and uppercase string, just write lowercase string and lowercase int, please, please, please. We will probably start preferring the other one.
It's just the same as var. Everybody should use var.
And the hands go up.
Du bist nicht mein Freunde. Wait, I think that was feminine.
One impact I wanted to call out from what Jared just said is that in the tooling, like in the ID and stuff like that, when you're looking at an IntPtr, there's a good chance we'll have to choose if we display that as an int or as an IntPtr. most likely we would default to nint the same way that we default to int as opposed to int32. But we'll have a discussion on that just to confirm.
Yeah, question from the chat that I think I asked at the meeting while walking out of it last week. So with the TFM based unification, so if you're compiling against net 7, there will no longer be a they typed inint here attribute on parameters and returns, right?
That's the discussion point we're going to have. We could have it here, but we thought it was kind of not for API review. It's, as Julian said, that difference becomes much more insignificant with this change. What it really comes down to is kind of two cases. Like, I think the easiest one to envision is, imagine you have an abstract, imagine you have like an interface that has where you put an int pointer in the signature, and you compile that into a DLL and you reference it, and then you type like my class implements this interface, and then you go to the IDE and you say implement interface for me. When they spit the code gen out, if we no longer have that attribute in code, the compiler has to make a decision. Do I represent that as nint, or do I represent that as IntPtr in the spit code? That's kind of that, as well as the same impact if you basically had a lambda that got attached to a delegate. Those are kind of the only remaining differences that come about if we remove the attribute.
Or quick info.
Yes, in quick info. Basically, it's how does the compiler represent when importing things from metadata? Do we show native int or do we show IntPtr? It's really kind of the fundamental. Now, we can keep, if we think that the distinction is still meaningful, then we can keep the attribute. But it means that the more and more you all use nint versus IntPtr, you're going to have more and more attributes, and David Wrighton will shake his fist at me for performance, and this is fine. But if we're comfortable saying that, if the whole motivation for this change is, listen, we want people to use nint, like IntPtr is it's a type that has a very singular specific purpose, and it's over here in the corner for opaque handles, then we can also just take the simplicity of just saying we always import it as nint and we move on with our lives.
Right, but the clarifying, so that is a good thing for the going forward, but the legacy TFM, the older TFM, if you are compiling for net standard, then it's the lack of the runtime flag means it continues to get the current behavior. Int is still a distinct type as far as C# import is concerned, and C# targeting with locals is concerned. And okay,
right. I think we would likely, I say this without, I'll let people correct me if they want to, but my intuition is that what we would do is, if we decided the attribute was no longer meaningful, what we would do is just say that based on basically the decision would come down to, is this the unified IntPtr? If this is the unified nint case where we're in net 7 and above, then we don't put the attribute out, irrespective of Langver. This is all just about because at that point you only get that with the .NET 7 TFM anyway. So we would tie all of the logic to that one thing.
Okay.
So, I mean, it seems like we probably should consider kind of obsoleting that attribute at this point, right?
Right. Honestly, I think that would be another fallout. If we said that we don't want that attribute anymore, then we push it away. But
And
I mean, it seems to me if
don't-
we wanted to, that seems almost like to indicate that there's an issue with the direction we're heading in, right?
Well, if the compiler completely stopped emitting the attribute, then that seems like it could create scenarios of compile breaks if a new NuGet package is built with a new compiler and somebody with an old version of the compiler is building against it, and it gives them an IntPtr versus inint mismatch because it understands the semantic difference of that attribute being present. That's the scenario that I want to make sure that is tested somewhere.
Well, it seems like we could change the compiler in such a way that if the runtime features flag is present, we keep emitting the attribute. If it's not, then we don't, right? So in which case it's the same thing. Like if you're consuming now a net 7 binary from net standard with an older compiler, we already said we don't support that, right?
Right. My concern is consuming a net standard binary produced with a new compiler while you're running on an old compiler. And I think Jared said, the lack of the runtime feature field will mean that the compiler will keep doing what it's doing today, and that
right.
That's the concern that I'm guarding against, and it sounds like we're good.
We also don't have any attribute to obsolete. We decided to never expose an actual attribute in the VCL. The compiler magics it every time.
Oh, we do? Compiler lead here speaking, by the way.
Yeah, I'm pretty sure this is the one that we went to review, and in I believe API review we basically said it's not worth exposing this attribute because it's only ever going to be emitted by the compiler. It should never be used by anyone else for like any other circumstance.
Yeah, I mean, I have to say, I'm on the one hand side, I like the simplicity of this. On the other hand, every time I open an assembly in ILSpy, I now get shivers down my spine. But yes, it's the same.
Okay. I mean, then we would just stop emitting it at that point, and it would just be a vestigial artifact that we forget about in a few years when, you know. So, cool.
And then we break
You
something
get-
with net standard 2.0.
No, you get a bug in Dev 24 when you break some corner case in VS because you removed that attribute.
Yeah.
You're welcome.
All right. Plan 2, go for the unification. Ship it.
Is that a unified decision?
Jeremy said so, so it is now.
I can
Here's
bang
the
a gavel if you want.
I was about to say, without a gavel, it doesn't count.
Plan 1 officially concedes, assuming that nobody else wants to speak up for it now that I've departed that camp, so Plan 2 wins. All right.
Gavel, or do you have a sound bite that you play? I
Actual
need to
gavel.
buy a gavel.
Some unnamed person sent me I received a package from Amazon that I did not order, and it was a present because someone thought that we needed more gavels in API review, and this was during the time that Emo's computer wasn't really working, so I was doing all of the reviews. Or I was doing all the hosting. No one has sent Emo a gavel to my knowledge. So we only have it on alternate weeks.
All right. So thank you very much for Jared, Julian, and Alexei for joining. You're more than welcome to stay around if you want to, but I think the rest of this is just going to be over the generic math interfaces. For the generic math interfaces, this is the design doc in .NET Designs. I'm going to give a quick overview of kind of where we were from our last review, and then go over some of the changes. So we have a number of core base interfaces that provides functionality such as iParsable and iSpan parsable to match iFormatable and iSpan formatable. We then expose various operator interfaces where the name is I star operators, where the star is the underlying IL opcode name. So we've got equality, comparison. We have a couple operators specifically for exposing a core concept such as additive or multiplicative identity. For the operator interfaces that have checked variants, we will be exposing both the unchecked and the checked form. If users want to expose these without taking any kind of breaking change to their public surface area, they are free to make these do the same thing, and they are free to implement them explicitly. That way they can, support generic math without breaking any of their existing customers if that's so desired. You look like you have a question, Jeremy.
I've never seen the syntax for explicitly implementing an operator. I guess because we couldn't have had it before.
Right.
It's going to be possible?
Yeah, it's going to be I addition operators, and then open bracket generics close bracket dot operator. You do it right in front of the operator. Notably, my syntax here is also mixed up. It is operator checked, not checked operator. C# had decided to change it from my initial proposal.
Okay,
But
so it would say
effectively operator is the start of the method name, and so you put the prefix there just like you would with any other method.
so static what's that thing that you do? Vector 128 interface with all the generics supplied dot operator space checked space plus.
Right, I'm putting it in YouTube chat now.
Okay.
Just to show an example for int, it would look like this.
Yeah, I mean I was gonna start with int and was like, but int doesn't actually have operators, so.
Yep, it will have explicit ones now.
But the okay, so the explicit implementation syntax for operators as defined on an interface has been addressed, and we'll be able to do it. Okay.
We have addition, we have subtraction. There are notes in various things of these on why addition and subtraction aren't joined together. They do not apply to all concepts or types, so they need to be explicitly different. Likewise, there are cases. Likewise, we take both the left, the right, and the result type as generic arguments because we have cases and users have cases where, for optimization purposes or other reasons, you want to support, for example, complex times double equals complex, or you want to support date time plus time span equals date time. And there's likewise cases where you do t plus u equals u. You've got all the various combinations there that may be valid, and so we explicitly take all three generic types for that reason. We likewise have increment and decrement operators. We have multiplicative identity, multiply operators, division operators, modulus, unary negation, unary plus, bitwise operators, which are combined together, shift operators, which will include the logical right shift, which is going to be included, and then in addition to additive identity and multiplicative identity, there's the ability to get min and max where that is applicable. There are cases like big integer where there is no min or max, and so you cannot provide that as a common thing for all types.
None of these interfaces implied a mathematical or otherwise relationship between each other. They're all standalone, right?
Correct. And so theoretically, if a user wanted to support combining paths using division like C++ does, they could implement division operators. They could make that happen and make that work. It doesn't mean the mathematical thing. We don't recommend doing that. We recommend following normal .NET coding patterns, and division means division.
Right, but if you wanted to use addition and subtraction from a finite field, then you would need your generic constraint to say both I addition operators and I subtraction operators.
Yes, assuming you wanted to support addition and subtraction and not also generally support one of the more complex interfaces we're about to cover, which imply I am a number type.
Okay, right. Yeah. So the ones that you went through now were the operator semantics only and the groupings that you have to do of if you claim this, you now have to define the whole suite of operators from that suite. Okay.
And the initial interfaces are building blocks because these are effectively the core building blocks or traits or protocols or whatever the language wants to define that terminology as, that are used to build up the more complex interfaces for every language and runtime that supports a similar concept. There's going to be users who are going to want to provide their own numeric interfaces or their own numeric-like interfaces, and these building blocks allow them to do that in a common pattern. The one annotation here, which we'll want to make a larger decision on later, is these are currently defined in system. iParsable and iSpan parsable probably make sense living there, as does potentially equality and comparison, because that's next to iComparable and iEquatable. For the rest of them, because they're kind of more rare and esoteric, and because they're kind of meant to be used with number-like concepts, there was a suggestion that we move them to system numerics. because they're not going to be commonly used or as commonly used. And so there was just the suggestion that we kind of move them off. So they're still not difficult to get to, but they're not necessarily polluting the normal namespace. I think the decision on that will probably come. We'll probably discuss that after I finish going over the rest of the overview. Now there was likewise an iNumber interface, a binary integer interface, and a couple other interfaces here, which I'm not going to go in depth into because these ones have actually changed based on community feedback. One of the primary changes here is that iNumber was suggested that we split it into two interfaces. For lack of a better name, I used the name iNumber base here. It's important to split this because iNumber itself supports many concepts that, particularly comparisons, that are not applicable to all number types. For example, complex numbers are not trivially comparable. And so it was suggested we split it into two. That way we can more readily support concepts like complex. Some of the alternative names suggested were that we call this one iNumber, we call this one iComparable number, or iScalar number, or some other name to keep it differentiated. I kind of went with iNumber and iNumber base specifically because iNumber is probably the core thing that most devs are going to want. When you start getting into the other number types like complex, you're thinking about more rare or esoteric scenarios that may require specialized handling outside the norm, and which users may not want to directly support in their algorithms. I don't have a strong preference there, and so my next alternative would be we call this one iNumber, and this one iComparable number.
Because our general guideline, which I don't even think is a written guideline, is we only throw the word base in if it's essentially invisible. That we expect 4 nines of developers to not ever see it.
Right. And the expectation here is that my expectation is that most developers won't need to deal with this. I expect most developers, when you're thinking of any kind of type, are thinking about things like integers, decimals, floats, rational numbers, and other various concepts where you don't really get into this doesn't have the ability to compare. Likewise, if you don't have the ability to compare, then you don't have the ability to sort and do all kinds of other really core concepts for utilizing types in user interfaces, in display, etc. So I don't expect it's going to be super commonly used. There will be subsets of domain-specific developers that will want to use this type, however, and System Numerics Complex itself would implement it.
Okay, and how was, for your current classification, how was the decision of addition, subtraction, and multiplication on the lower interface, and division is only on the upper interface?
I had a note about that, and that division we may want to move division up to iNumber base, but it needs just a little bit more research into some of the other types that third-party libraries are interested in doing. Complex does implement divisibility, and I believe most types that support iNumber base would also support divisibility. But I wasn't able to finish collecting enough data to say with, like, let's say a 95% confidence that it should definitively be there.
Okay, because if I remember my math training, wow, words, the addition and subtraction is a field, and then multiplication and division is a ring, and so generally you see the two paired things together. So it feels weird to me that this one's split across, and that maybe there's a reason we would want the field broken off as a separate interface. And then if we thought that it was important to have field and then field comma multiplication and then ring, again, we don't have to use the number theory, etc. names, but I just wonder, are we making these shapes because we have some convenient bucketing, or are we making these shapes because they're rational?
I think both. We're trying to, like Steve just said in chat, we're bordering on an obscene number of interfaces. The interfaces have cost. There are limits to what we want to do and want to support. We ultimately cannot support everything every developer may want to do, even for these core numeric-like interfaces in the BCL. That's why my original design actually kind of pushed complex off and didn't consider it a number. The only reason I've come and added this is because there was a significant amount of feedback from interested parties requesting that we specifically support complex in this interface, as well as similar higher kinded math types. And so I'm trying to find the balance here between this is what most developers will need and this is what is actually being requested via feedback.
Yeah, I would like so I don't personally need to see the split between a field and a ring, but it feels weird that we have a field plus as the interface. So I'd be happier with this if division moves down into base.
Yep. I think that's
I'll then also move on to the next line. There is, why do we not think that complex is span formatable?
Okay, so so span formatable and span parsable, there was this is one where I'm going to try not to offend people. There was a significant number of very noisy users who believe that they should not be forced to implement parsing and formatting support on their types. I do not agree with those people. I think parsing and formatting is a primitive operation that any type should support, at the very least for debuggability and display purposes. And so I mostly didn't move that one down, so I didn't have to continue trying to triage comments of people saying I don't want to have to support this type or this interface. I believe that parsing and formatting should likely be on iNumber base. There is a question on, we had previously said we wanted to keep iParsable and iSpan parsable separate, not only to mirror formatable and iSpan formatable, but also because we didn't want to force users to implement span support, because that is a quote unquote more complex scenario. Having the interface implement span variants means that users implementing these interfaces, which we may or may not consider an advanced scenario, means they will also have to deal with span. And so there's kind of a question there of if we should just have iFormatable and iParsable move down, or if we should just have, or if we should move iSpan formatable and iSpan parsable down, or if we should only have iParsable and also have it include span parsable, because people implementing this really should just support both moving forward.
Yeah, I mean, I think if we need the distinction of comparable numbers and non-comparable numbers because of things like complex, that is reasonable, but that otherwise we should basically everything after I comparison operators on iNumber should move down.
Including modulus?
I don't understand division without modulus. Like they feel together. If you like,
that's fair.
Again, we're either making the super explosion of all combinations of things, or we're saying if you want to define yourself as a number, you support a mod you support the mod operator. What does your mod operator do? It can throw.
Okay,
but you have to declare it.
And so I think with that, if we're going to move everything down, we'd be left with a surface area that looks like just because I don't have another place to put it. And suggesting the name here, we'd have I number, which is what currently is I number base, and that would implement, in addition, I division, I modulus, I span formatable, I span parsable, and we would then have I comparable number, which is which implements I comparison operators and I number base.
That seems reasonable to me. Anybody want to otherwise assent or dissent? Kathleen?
Yeah, quick question. I'm sorry, I span formatable. What's the, do we also need non-formatable next to I span formatable for those languages that, those places that span's not supported? It's kind of a yes, no question. I don't need a deep conversation on it.
I span formatable implements I formatable.
Okay, fine. Great.
Yeah.
Okay.
And one of the presumptions here is that because this requires supporting static abstracts, if you're going to go and do the effort of supporting static abstracts, you should probably support span as well. There's enough concepts in these interfaces where it's important for perf, particularly with the core primitive types, that a language, if it's wanting to support one, should probably support the other, or it's going to run into complications.
Okay.
Stepped away for a second. I might have missed. You might have said this. Sorry, but why did division and modulus get moved up? I assume the stuff in. Sorry.
No. Finish your question.
I assume the stuff in the chat is your proposal for I number base and I number changing, right?
Yeah. So division is supported on complex. The only reason I hadn't moved them up already is because I hadn't done enough research and feedback to ascertain with like 95% certainty that it would be good enough. I was pretty close to determining that, and I just had run out of time to kind of finish the research I was doing there. My belief is that for, particularly when we're considering what users will typically want to support, that it's going to be good enough. And if you're in a really rare edge case where you're trying to represent something that doesn't support division or reciprocals or anything like that, then you're probably best off building your own interface for your domain specific scenario.
Okay, that makes sense.
I'm keeping track of the notes locally as well, since this is a design doc and it's not so trivial to leave API review notes directly there. There is a PR, it's PR 207 if you want to drop the notes there after Jeremy.
Okay.
So I number will expose 1 and 0, and there will potentially be a couple of these that move down accordingly. I'm going to skip over create now because that's a slightly different topic that I need to cover separately. But we're going to continue having support for absolutes. Because this one's comparable, it will support clamp. There's the concept of copy sign, which used to be floating point specific, which will be brought down to number because it generally makes sense for numbers. It copies the sign of one value to the magnitude of the other value. For unsigned values, that would be a no-op. For for sign values, it will do the expected thing and actually pull the sign. Likewise, we would move the isNegative API down here, which allows you to trivially determine if a value is negative without having to do other comparisons or checks. There was a question on whether we should support big integers is even, is odd, and is zero. Is zero in particular is one that the IEEE spec recommends, but we never exposed. Is even and is odd seem like they would generally make sense for integers, but potentially not for floating point, unless you're only considering the integral part there. I did not have a preference on if we exposed them or not.
And we generally expect to be able to add them later, right? Thanks to DIMs.
Yeah, we would be able to add several of these later via DIMs and potentially less efficient implementations if we decided at a later point that it was a mistake not to add them.
Well, but
I mean,
we couldn't
how do we generally
functionally add it.
I was about to ask, yeah, like I didn't really think this through. So like, what's our, like, how would we implement them then? Just having them throw?
You would likely end up doing a truncate operation. So you'd force around, and then you would, or you would cast to, for example, big integer, and you would do the corresponding check of, is the integral part even or odd? It would not be efficient. It would just be a fallback implementation for people who have not implemented it yet.
Right, but you know, if you've got complex, like I don't think we have anything in here that guarantees that you can pull it into a type that you can reason about. So there's no notion of being able to ask it, what does evenness even mean?
Well, that's why is even is on comparable, the comparable number, not on the one that complex would implement.
Okay, so I guess part of my brain assumed that all of these were moving down to iNumber.
No. Abs could, is negative could, clamp could not, copy sign could, max and min could not.
I mean, it generally seems like things that actually have behavior would be very hard to add, right? Because, I mean, the best we could do is basically have an implementation that works for the built-in types, right?
Right.
But generally speaking, we wouldn't be able to add, let's say, clamp later if we wanted to, right?
You could add clamp by definition of having max, min, and comparisons. Part of these interfaces is a contract around what it means to be a number. And if you're going to decide to support something that is outside the concept of number there for what .NET defines it to be as, then you're not going to be supported. We have to make that distinction, or we cannot version any of these moving forward.
Yeah, I think I understand that. I guess what I'm heading to is like, you know, in practice, I'm wondering how successful people are with implementing this on their own types, I guess.
I imagine for most types it will be fairly simple. If you're talking about an integer type, you're effectively talking about take the magnitude and mod 2. If you're talking about a floating point type, it's likewise extract the integral part and mod 2. In many cases, it's even simpler than that, as you're able to do a bitwise comparison with your underlying data format. So users should generally be able to, particularly if they're supporting more advanced numeric types, easily determine these concepts.
Yeah, I guess, I don't know. I mean, if I implement this on, let's say, my own complex, I guess a lot of the stuff just comes down to me just forwarding it to the underlying fields, right?
Right.
Which is just a lot of typing, but
yeah,
it's not difficult.
And complex numbers are a case where the concept of even and odd is somewhat hard to define, because there's both the real part and the imaginary part. And so you could have 2 plus 3i, in which case defining whether that's positive or negative is difficult. And so this wouldn't, so is even and is odd would not move down to complex. They would only be on the comparable.
I guess that is my question. Like, I mean, I think I can reason about these APIs in terms of primitives. I think I have a harder time reasoning about, things like complex, where I actually have a legitimately custom type. And it seems like just for validation of the API service, probably would be good for us to try to implement this on a non-built-in type to just see, oh, do we have some crazy APIs that we just don't know how to implement on those? And then maybe we should just move them somewhere else.
Yeah, and complex is currently being used as that building block, and that's different. That's allowing the and for all of these that are on iNumber base, it is I'm looking at how to implement them generically to ensure that something like complex could implement it generically for versioning over time.
It is like a good mental model to say, like, I should implement iNumber base versus iNumber.
Most users should just implement iNumber, which we've determined should be named iComparable number.
Gotcha.
Most users will be dealing with standard, what most users think of as standard numbers or real numbers. And so they will just need to consider the concept of basically a single value or represent or something that's representable as a single value. Whereas complex is, it's really not representable as a single scalar. You couldn't build a machine that represents it as a single scalar. There are two parts to a complex number. And there's probably going to be some math people that are mad at me for saying that, but complex is fundamentally a real part and an imaginary part, and an operation, generally addition or subtraction, combining those two parts. And that's distinctly different from a rational number, which might have a numerator and denominator. It might also have two distinct parts in metadata, but it is still representable as a single scalar value. It is representable as a single real value if you were to compute the result of the numerator and denominator. And that's kind of where you get into the distinction between how math works and how programming works. Because programming has to actually represent the distinct concepts there, and convert between types when you want to change the view of the world.
Yeah, I feel like floating point already broke into that jail pretty badly.
Yeah, so Tanner, regarding the operator interfaces, there was a question in chat of what does polymorphism do with any of these. So if you have type B extends type A, and you have I addition operators of self, comma A, comma A, what, if anything, happens?
I believe the compiler will allow the implicit down conversion of B to A because B derives from A, and then allows the operator to work. I believe that's exactly how operators already work when you define. But effectively, operators will continue to work as operators have in C# in the past. So if you were already defining operator plus AA on an unsealed class, and then create an instance of B, it would work exactly like that does today for that scenario outside the interfaces.
Right. But since all these operators or the interfaces are all, you have to define the self. So whenever you accepted the self, you've defined whose version of the operator is going to get called. So
right.
The fact that A was not a sealed type and accepted an operator plus means it was willing to expose the loss of data of a downcast.
Right. There's in general, you probably shouldn't be implementing most of these interfaces on unsealed classes.
I
agree. You should seal your types by default. You should make extension an explicit design goal, and because you cannot create virtual static operators today, you also can't override them in a derived class, so you have to take that into your design, and consider that that you're going to be stuck with that A implementation unless you also separately implement I addition operators, B, AA, etc.
Right.
I mean, yeah, I think this squarely qualifies under the like if it hurts, don't do that thing. But it's also possible that we're probably going to want a suite of analyzers with all of this anyway, which can be discussed at the appropriate time. And one of those can probably be like, hey, you've implemented a concrete type that has these interfaces hanging off of it. You really need to steal that thing.
Yep. I expect that most code out there, like most C# developers, will likely only use this with the BCL types. There will be some libraries that provide their own types, and people who use those libraries will also use the numeric types and be able to use and extend them. And so users who are providing their own int128 or int256 or their own big float will be able to plug into the existing ecosystem.
Yeah.
Otherwise, it will be domain specific, and there'll be their own interfaces supporting everything.
To retreat slightly to the iNumber base, iNumber, iComparable number, I do feel that the average developer would just think number, and they would think the comparable number. So instead of iNumber base, maybe I non-comparable number. I mean,
That works for me.
Technically,
as well,
that's
and I
asserting
like that
it's not
better.
comparable, but it's really the I'm an iNumber without the comparison constraint. And I think I'm willing to live with the weird name for the edge case.
I may be uncomparable.
Now you're just making sentences.
I'm generally fine with the less likely to be implemented one, the non-comparable one, to be a more complex name, and that's why I originally named them iNumber base and iNumber.
Yeah.
But the naming is, one of the hard problems in programming. So.
Indeed. So I'll take a note that that's a proposed alternative name, because I don't think we're going to get anything called approval in today's meeting. But
yeah. So moving forward, that way we're because we're kind of short on time. It took a bit long to review the first two C# issues. We have max, min, and then we also are bringing down max magnitude and min magnitude. These were previously only for floating point types. They are more generally applicable. It picks the larger of x and y in magnitude. So if you were to take the absolute value of x, the absolute value of y, and compare the two of them, it would return the original value of whichever one was bigger or smaller, respectively. So -2 is returned if you do max magnitude 1, -2.
And is negative moved to the base interface, right?
Right. Abs copy sign is negative and is 0 if we say is 0 should be approved, and I believe it should because it's recommended by the IEEE spec. Would move down.
But clamp did not?
Right. Clamp did not because that requires max and min, which requires comparing.
Gotcha.
Question on things like max and min, and I don't know how compiler CPUs whatever works, so maybe it's a silly question, but would it be more efficient to have these APIs return, say, the index of which parameter was the max or the min rather than the value itself? Like, is there any potential for optimization there?
If you have a large value type where the copy is prohibitive, then yes. Ideally, max and min and the others are small enough implementation or are hardware accelerated such that they get inlined, the copy is elided. It will certainly be elided for all of the primitive types, in which case returning the actual value is the standard way to do this, the standard way to chain operations, etc. You end up with much more complex code if you have to return an index and then use that to determine, and then use that in a branch to determine X or Y, etc.
Yeah, the reason I'm asking is like if you consider APIs like max magnitude, min magnitude, they would be trivial to implement on top of abs and a max or a min that returned an index rather than a value, because now you have to have a comparison. If again, like this is probably by naivete about how all this works at the base level coming through, but I was wondering if there is any scenario at all in which it actually makes sense, and it sounds like the answer is maybe vanishingly few.
That would be my expectation.
Great.
Moving on, we have two parse methods which aren't part of any parsable like interface, which represent the ability to parse a number, because they take a number style, allowing support for hex, etc. We have the method sign, which with the presence of is negative, is 0 in the other APIs, I'm not convinced this is worthwhile. This API in particular is a fairly .NET specific concept. Likewise, the recommendation is not to return tself here, but to return int, because that's the current behavior for all of these, and the allowed values are only 0, 1, or -1. It's never anything else. The downside of returning int is that if you end up needing to use that to create a T number, you have to go through create APIs, but for this API in particular, if we expose it, that's deemed, worthwhile.
Yeah, I mean, this does hit the standard unfortunate thing of interfaces of they define syntax and not semantics, and you can define a thing that says sign that returns 27. You just shouldn't.
Oh, no, interfaces definitely define contract. IEquatable has a strict contract on exactly what is allowed and what equality means, and if you go outside of that, then dictionary is going to break. Interfaces definitively define contracts, including what allowed return values are.
Yeah. So I think you're thinking probably compare to, Jeremy, where it can be like any positive or any negative value or 0.
No, I mean, we can write in docs what it's supposed to do,
Yeah.
but just because something adheres to the interface and has a member called sign doesn't mean it's going to behave the way that we write in the docs. That's the general thing that's true with interfaces, and why interfaces are useful when you need the syntactic thing like generic math, but they are not useful when you need a semantic thing, and that's what we have base classes for.
Right, and if a user has an existing sign method that does a different behavior, then they can explicitly implement the interface one here. Decimal in particular already exposes a sign that works like this one does.
Yeah, and this also matches math.sign, which says explicitly you must return one of these 3 values, 1, 0, -1.
Well, but math.sign is a function. It's telling you these are the only
yeah.
things that come out.
Yeah, but I mean, I think the idea is you're providing an equivalent of that here.
Sure. I mean, like similarly, just because it says max doesn't mean that they actually do the thing. So we're trying to say what a sensible set of behaviors would be, but at the end of the day, this is the semantics versus syntactics, and interfaces are just syntax. But okay, so sign moves down. So far, clamp's the only thing that stayed behind, I think. And so the reason we have the parses here is they accept number styles, so they're slightly different than the ispan parsable, but so these parses and triparses both also move down to the base. Okay.
Yeah.
So we have whatever these creates are, and clamp are the things that we haven't moved, but we didn't talk about create.
Yeah, create I'm going to cover later if we have time. I actually doubt we're going to have time.
For things like for numbers that can be nan, for instance, or infinity or something, where APIs like sign might not make sense, would we expect those implementations to throw?
Sign makes sense for nan. Sign makes sense for infinity. There is both negative and positive infinity. Floating point spec defines both positive and negative nan, and has an explicit defined behavior of what that means. If you're supporting concepts of infinity and stuff, then in the worst case, you can always return 1 if it's only ever positive.
Or I'm looking at the implementation of math.sign right now, and it does in fact throw for nan, even though there is a concept, like you said, of positive and negative nan.
Right, and that's a both a perf issue and a implementation issue that we've not gone and taken to review yet. Those really should be updated to be IEEE compliant and not throw in those cases.
So is the suggestion then, and this comes back to the conversation that you and Jeremy were just having a second ago, like, is there a world in which these APIs could throw an exception somehow, or would we say the only valid implementation of sign ever is that it returns 1, 0, or -1, and if you do anything else, including throwing an exception, like, your caller is going to potentially have undefined behavior?
That is my desire for most of these APIs. There are cases like parse where we expect, for example, null strings to work for try parse, and we expect them to throw for parse. And if a user's not doing that behavior, then you're kind of in undefined land.
Got it. So for some of these APIs, we would explicitly document them, for instance, sign as this API must not fail.
Right.
Okay.
And are we getting DIMs with these in this release?
So the runtime has already added partial support. The plan is for the language to add support if they have time. It really comes down to how much Alexei can get done out of the 4 things that are on his plate. Checked operators are almost done. Relaxing the shift requirements is supposed to be fairly easy, as is supporting unsigned right shift. Most of the work for those 2 is supposed to be just tests, in which case ideally we have time to get DIMs in, and if it is, we will take advantage of DIMs for various APIs where possible.
Right, because it'd be really nice, for example, if we just say the interface, unless you overwrite parse manually, it will just be try parse, and on true return the answer, and on false throw. And because that is
right.
That is the behavior of parse.
Right.
And
moving down, we've got ISigned number. I think based on the previous change, the previous decision, we can just drop the base part. But we've got ISigned number, which exposes -1, and I unsigned number. This is so users can actually differentiate if they only work with signed types versus unsigned types. It's generally recommended that users just rely on checking for negative values instead, using the is negative API. But there are a number of algorithms and cases in other language that explicitly use and check for signedness in their constraints. So it's worth exposing for us as well.
Since I don't see the sortable version here, would we need this to be the treatment we give the base type to this one, or would it just be ISigned number?
It would just be ISigned number, and it would implement the non-comparable one. It is kind of a side interface, and if you want signedness, then you explicitly check for both constraints. So if you wanted a non-comparable signed number, you would check for ISigned number itself. If you wanted a comparable signed number, you would check for comparable plus signed. We could even actually drop the inheritance here and just have them be completely standalone if we wanted, effectively marker interfaces, so that you always have to check for both of them together, if that's your desire.
That seems... yeah, that seems making it be a marker seems better than an inheritance here.
That makes sense.
It takes away that whole signed versus or comparable versus non-comparable question.
Mm-hmm. We continue to have binary numbers, which just extends the existing numbers with bitwise operations, and then an isPow2 and a log2 method, specifically because it's binary. We have binary integers, which extends it with divrem support. This previously used to be down on number, the comparable number, but it was moved off because of the confusing semantics related to floating point. This is specifically because it's div and rem at the same time. It's not necessarily the same as division and modulus, because it's specifically returning the integral quotient and integral remainder, rather than necessarily the other operation, which is it returns the floating point divided by floating point returns just an exact number that includes the partial result already as part of the main.
Are you telling me that for floating point, a divided by b plus a mod b is not a, and not even counting the cases where you ended up with numbers that can't be represented when added together?
Right, because 5 divided by 2 is 2.5.
And 5 mod 2 for a double is has an answer?
I think 5 mod 2 is 3 still.
Oh, okay. Okay, so the notion of divrem therefore is
no, it's 1.
Is
it's
entirely
1. It's 1 because 2 times.
So modulus and double is treated as if it's an integer, even if it's not. Okay.
Yeah, there's this weird thing in how it works due to C-compat, and then there's the IEEE remainder function, which is separate.
Sometimes I don't know why I ask questions, because I really don't like the answers. Okay.
We add support for leading zero count, pop count, rotation, trailing zero count, and shift operators in general to ibinary integer. And then the functions that support getting the underlying bits for the integer, like big integer provides. Big integer calls these try write bytes. I took a leaf out of Vector's book and called them copy2 and try copy2 instead, specifically taking byte. But these allow you to get how many bytes are in the underlying. So get byte count gets the number of bytes that make up the entire data. So long would always return 8 for example. And get bit length returns the shortest bit length for set bit. So it's essentially a helper for getting the leading zero count minus the byte count. So if you had 255 on a 32-bit integer, get byte count would return 4, get bit length would return 8. Both of them allow you to easily determine, for example, without copying, whether there's overflow, whether something would overflow without needing to copy.
So get byte count is related to copy or try write or whatever we want to call it, and get bit length is the size of the type minus LZ count.
Effectively, yes. And that's exactly how big integer works with these same named methods.
Sort of. Big integers. For big integer, if you had 255, get byte count is going to return 1 because it can copy only 1 byte. It copies the minimum representation.
And that's because big integer is variable width.
Right.
So for a variable width type, it would return the number of bytes that are actually being used, and therefore how big the span you need to copy into is.
Right. So now, like with what's on the screen right now, we run into where I feel that we can't ship this without dims, because no one should need to define all three of these copy2s.
Right.
Like either we pare down the interface and say you have to deal with the spans, or we get dims and then the world is happy. We can alternatively do both, and we can pare down the interface and only add these once we get dims in the interface, or dims with static abstracts.
Yeah, I think that would be the best approach, is we just have the spans, and assuming we get dims, we also provide the byte overloads. That would put VB at potentially a disadvantage, but VB's already going to, I don't believe it's going to be able to consume these static abstract interfaces, so it would only be able to consume these as instance methods anyways.
Yeah, and I mean, this is a weird, because this is an instance. Oh wait, this is actually just an instance method, right?
These copy methods are specifically instance, not static.
Right. So these can be dimmed.
Yes, actually, that is correct.
So copy2, again, assuming we don't want to discuss right now the should we rename copy2 to try write bytes. If we're happy with the name copy2, all three of the copy2s can be written in terms of try copy2 as a dim.
Yes.
And then try copy2 is actually now you have to go write this one, because we're not going to perpetuate the span one calls the non-span one and then doing renting and other nonsense. So
yeah. The one note is that we are returning in uint here for the size, because that's technically correct, but we should probably change this to be int, since we only support copying to a span anyways. And then get bit length would have to be long accordingly, since you could have array max length times 8, which is over int32.max value.
I'm good
I
with
feel
it.
your pain. Yeah. I feel your pain, Tanner.
Even though unsigned is correct, that goes against our general pattern of only use unsigned when there's a extremely limiting reason that you have to. So
right.
So I was going to object to the use, but I'm also happy to take the ins away.
So what's the scenario for this? Is it just to literally duplicate it in memory?
Also, there's going to be cases where people, and this kind of gets into the create API that if we go over time here, we could hopefully get around to discussing. With creation, you have a case if you've got an arbitrary t that you need to create, and you've got an arbitrary u value that's already existing. Because you don't know what that u is, you need to be able to somehow convert that to a t, including in cases where neither type knows about each other at all. And so this effectively provides a fallback mechanism to efficiently, or about as efficiently as you can generically, determine, will this fit in my current data type? So you can decide truncating, saturating, or throwing behavior. And then if it will fit, you can get the relevant bytes out and interpret them as a binary integral, because it's two's complement bit representation. So you can actually interpret those as the relevant integer value to construct your own type. For cases like the primitives, that's effectively just copying the lowest n bits. If you've got your own type, like let's say you're doing binary coded decimals, then you'd end up having to do your own conversion of the bitwise pack data. But because it's in a well-defined format, you can successfully do that.
Okay, so it sounds almost like it's a reinterpret cast, but with the ability to do a transformation in between.
That's basically what it's there to support.
Because you probably see where this is going. What I'm afraid of is that people will use this and then like write it to a like a binary stream or something, and then they'll end up like writing out stuff that can't be received on the other side because maybe there's like an Indianness change.
Yeah, for big integer we added we have the Indianness argument in the try write, and we also have the pretend you were unsignedness that I needed. But this doesn't have those, and then also the span writing copy 2 should ideally return int.
Right, to specify how many bytes were written. So my preference for the Indianness is we do what Swift does. It's little endian always. If you need to convert those bytes back to big endian, that's what bit converter or system buffers, binary primitives, binary whatever dot read and write big endian are for. Little endian is by far the most common, the most popular, except for networking, and many other languages just say for the byte arrays we return for getting the raw underlying bits, it is little endian.
And if we want to, put a stake in the ground and say this is what we do, like I'm totally fine with that. It sounds like you've given this significant thought.
But again, if we're going to do that, I think we should call it copy little endian.
That would be fine with me as well.
And then, because it's an instance method, someone can write an extension method that is copy big endian that says call copy little endian and then reverse the write.
Yeah. So just copy little endian, or do we want write bytes little endian? I don't have a preference there.
I mean, no matter what, we're going to have to explicitly implement it on big integer, but
yep.
Do we use, so aside from vector, do we have any other place that we use copy to change representation? Because we have stream copy to stream. I feel that generally a copy to is an A goes into another A, not a goes into a B.
Yeah, there's most of the places we do T to T, vector, and there's a few buffer areas and a couple others that do potentially T to byte, and whether we use copy or write kind of varies. I didn't have a strong preference for either of them.
I feel like, I think in my head, write little endian and try write little endian is the different kind of write way to go. But possibly I'm just tainted by the fact that we called the span writing stuff the try write pattern.
That's fine with me. Yeah, so I think it would be write bytes little endian, because that's what we do in binary primitives. We do write type, or no, I guess it would just be write little endian, because that type is the T that's coming in, not the byte buffer that's going out. So just write little endian.
Yeah, I think write little endian and try write little endian is good enough. Anybody else want to agree or disagree? Looks like we're a two-man show here, Tanner.
Moving forward, there's some interfaces that were split out because one, they represent a lot of complex functionality that not every user needs to implement when they want to support things like floating point. And two, they also apply sometimes to big integer, to complex or other types. And so these used to be specific to binary floating point, but now they're broader, and so we've got I exponential functions, which exposes x and scale b, which is effectively the inverse, as well as the approved but not implemented helper functions that provide additional precision where applicable. And I didn't have a preference if these were pulled off into another interface for IEEE. I leaned towards not, just because reducing the number of interfaces where possible is general goodness, and this was a place where that could happen. There's the hyperbolic functions, the logarithmic functions, the power function, which is just pow today, and the root functions, which includes cube root, hypotenuse, square root, and root itself. And then, of course, the potentially the most important ones, the trigonometric functions, which includes the standard cos, sine, etc., and calls out the approved but not implemented pi variants. We then get onto iFloating point, which was pulled out to better support both decimal, which is its own type, user-defined rational like types, etc., and the IEEE floating types altogether. And so it just extends a comparable number and also supports ceiling, floor, rounding, and truncating. So just generally the rounding operations.
Sorry, let me interrupt you real fast. On our internal stream, we've lost the screen.
Oh. That's not supposed to happen.
I don't know what YouTube's seeing right now.
They're seeing what I see on Teams, which was a bunch of big headshots because no one but me has their camera on.
Yeah, we're back.
Just to go back and scroll through the exponentials, the hyperbolics, the logarithmics, the power and root and trigonometric functions. Then floating point, which generally supports the rounding, various rounding modes. There's an open question on whether this should generally support any kind of integer type or whether it should be restricted specifically to int. It is highly unlikely someone is supporting supporting something with more than 2 billion digits in it. If they are, they're going outside of the realm of what the GC can support anyways. So it might be reasonable to just force this to be restricted to int32. Which would also remove any concerns around being doubly generic. Does anyone have a preference on that?
I mean, it seems good to not be doubly generic because there's, I don't know, a way that anybody can write it. Right? How do you say that you can round yourself to any arbitrary integer? Like, you don't know what that integer looks like. That may come back to what the creates are, but
yeah, you'd end up, I think, at best having to convert that to a type that fits however many integer digits you support. So you do int dot, create from digits, and if you want to overflow on that, you would do create overflow or whatever, or create saturating and then do a check and throw.
Yeah, I mean, defining round as you take int32 now, and if we find later that we need to, then we'll figure out what that means later. Like, that we dim it using, can it convert the input type into int32, great, it can call the current one, otherwise it throws, and that's all that the implementing types would have done anyway. So.
We get to the floating point types, which the IEEE floating point type, which supports the previously mentioned functions that IEEE requires. It also exposes the mathematical constants e, pi, tau. pi is cased like math. However, elsewhere, such as for sine pi, we decided that it should be capital P lowercase I. Because pi is not a acronym or anything like IO, I actually think that the math API is named incorrectly, and we should probably decide officially to change this to capital P lowercase I.
Good with me. I understand that there would be some asymmetry there, but if you're pulling it off the interface, you'll get the we spelled it correctly.
Yeah. We then have the bit increment and bit decrement APIs. For integer types, this should be equivalent to plus plus and minus minus. For floating point, plus plus and minus minus are plus 1.0 and minus 1.0, whereas these are literal bitwise increments and decrements, and work just like the APIs on math and mathf. Use multiply add, where this is not XYZ, this is actually left, right, and addend in source. We had previously determined that was the correct name, because left and right are multiplied and then they're added to the addend is added on top of that. We wanted more readable names. We have IEEE remainder. Notably, this is another case where the existing math casing is all caps. However, based on convention, this should actually be capital I, 3 lowercase e's remainder. And that's likewise the casing of the interface there. And so I would propose we actually take a break from math and correct the casing. This one I have less of a preference on, but consistency between the interface and the method name would be nice if possible.
Yeah, I don't know why, but to me, like I was gonna say, sure, we should lowercase all the e's and it matches the interface, and we have in crypto somewhere IEEE pops up, but and we did little e's, but for some reason at the beginning of the type name it looks the big I and the 3 little e's looks a little weird, but I think consistency with the naming, and we should just go with little e's. Yeah. Anyone want to disagree? I mean,
we could also, if it helps, we could insert 754 after the IEEE, which I think helps with the readability and difference there. But that would be a further difference other than just casing.
I took a note.
Okay. We then have some of the core constants. So we've got epsilon, which is defined as the current epsilon is. It is the smallest epsilon, which is the smallest value greater than 0. The smallest representable value that compares greater than 0. That's different from the C epsilon, which is the smallest representable value that compares greater than 1. This epsilon is what .NET has always exposed, and it is the epsilon on which all other epsilons are built. So all other epsilons, including the smallest representable value greater than 1, are a multiple of this epsilon, which is why .NET had originally decided to use this epsilon instead. We've got nan, negative infinity. We explicitly have -0 and positive infinity. We then have the helper functions for determining is it finite infinity, nan, negative infinity, and it does the right checks, whereas normal comparison may not work or account for all of these scenarios. We likewise get to the specific compound function, which was approved but not yet implemented, and the max magnitude number functions, which are specific to IEEE and return the max number ignoring nan. So the regular max function, nan is propagated, whereas with these ones, nan is not propagated. And then, like for binary integer where you could get the raw underlying bits, there is a function to get the, there are functions to get the bits for the exponent and the bits for the significand.
And those would all get the same copies become writes.
Yes.
I assume we'd want copy exponent little endian and then just and not have the two.
Yeah, I think write exponent little endian.
Oh yeah, right exponent. Yeah.
And then I just have a docs list covering the rest of the IEEE functions as specified by the IEEE spec, detailing why all of those above are required. You specifically have I-binary floating point, which is somewhat of a marker interface to indicate this is a base 2 IEEE floating point number versus decimal, which if we ever support in the future, we would want to expose. This one's not actually proposed for exposal in 7. And the functions that we would need to support if we supported decimal 32, 64, and 128. There have been user requests, but that's kind of a out of scope for .NET 7. And then the one other thing is covering the create APIs here, where I kind of have a gist doc covering things here. So with the create APIs, creating is probably the most complex part of any of these interfaces. It's complex because, like I described earlier, you have an arbitrary T, which is the type you want to create, and an arbitrary U, which is the existing type. In the worst case, you don't know what either type is, and you may have to do type checking, such as if U is a binary integer, then extract the raw bits and build it up. That was kind of the approach with these create APIs in the first place. Supporting it is complex. You have to do individual support for each type you want to directly support. In the worst case, you may do something like this, which is if the value is a binary integer, then copy the relevant bytes out and convert. And in the absolute worst case, you may have to actually throw. If it's, for example, a custom domain-specific interface, you have no ability to recognize. And so while the create API mostly works, there are it's somewhat difficult to, and the use of such a create API is very trivial. The use of such an API, or the implementation of such an API is incredibly complex and somewhat error-prone. One of the suggestions was instead we support iConvertible to and iConvertible from interfaces. One of the immediate problems here is this is a huge explosion of interfaces, especially when you want to support the primitive types and support them bidirectionally. The implementation is quite a bit simpler. There's less generics involved. You could maybe mitigate some of the explosion there by also having some kind of expressible by primitive interface that joins them all together. And usage remains simple. But you still kind of have complexities of like, well, how do I actually consume this? In the best cases, you have to constrain where T is iConvertible to. But that runs into the problem of, what if T doesn't know about T other? What if the contract is the other way around? And so you would have to then constrain where T is iConvertible from, and you run into issues of, well, you can't overload based on constraints. You can't provide both constraints because it's going to limit cases that actually exist. You're going to have to implement 2 methods. And so I basically said, this is a bad idea. It's worse than the first idea. After a lot of thinking, I came to a proposal which I think kind of tries to mitigate the worst case scenario here of having to throw. which is we slightly modify the syntax here, and we define a new interface, iNumber converter. iNumber converter is just a standard interface that defines the ability to convert between one number and another number. The create API will then take the converter, and we would, in the BCL, provide a built-in default implementation of this, just like we provide comparable.default and equatable.default. And so the implementation then becomes quite a bit simpler if we still want to expose the create APIs. But the key thing is that it allows the user to support conversion. Types can directly support conversions where that's beneficial, and they likely will for the primitive types. But if there are two types that don't know about each other, that don't support each other, or that are domain specific, either type implementer or the consumer of those libraries would be free to go and roll their own number converter that allows performing the conversion between both of them. So it's basically just a way to inject a custom converter to do the conversion where otherwise you would have to fail. And this was after many months of thinking, prototyping, and trying to go through various things. This was what I came to as the overall best and simplest solution that left the implementation still simple, because we could simplify this down to be just create value, but where it still allows the extensibility for a user really needs to support this conversion and they couldn't otherwise.
So you say we can simplify this down. Does that mean that we would dim the create as calling it with number converter defaults, but that may not?
Right. It leaves it as a
where would that fail if you use something that number converter default didn't exist for? Would that be if you tried instantiating the interface, it would say you must override this member because its body can't be lifted?
Let's say that a user goes and implements iNumber or the non-comparable number for a custom complex type. Complex itself can't be represented as either a binary integer or as a floating point value, and so you wouldn't be able to use the existing generic write little Indian APIs to get the raw bit representation out. You would have to specially understand how complex represents itself to support it, and so number converter default would never be able to support complex out of the box without hard coding it. And the list of types that could be potentially supported is, infinite, because anyone can define their own type. So this provides a way to avoid the failure case in the scenario where you're supporting where you've got potentially two types that aren't convertible to between each other.
Yeah, I understand the long line. I understand 163. I just don't understand how we could make 162 work.
Oh, this is just this. So it's just a friendly API where the comparer is number comparer default by default. It's just like we have interfaces that support IEquatable, and if it's null, we use equatable.
Right.
Default.
So it's not passing in number converter default. It would pass in null. And everybody's supposed to do that. Well, because it's if number converter default says that it does ICreate from and to in 700 combinations, but then you can't put that in an interface that can't adhere to, you have an unspecified T. It shouldn't, somewhere in here that would fail if it was written as a dim, I think. But if we say that the convention is null should be number converter default, then that's that I think we could write, and that could even just be a default argument in the, of course. Do we feel that statics and interfaces should not have defaults? Because that's what we said for instances and interfaces. But.
the API here would be so we'd end up having both of these, and then this one would just be return create value.
Right,
member.
but who's gonna? Is that supposed to be callable on a T, or is that just supposed to be on all of our built-in types? We will define the simple version.
We would define the simple version as a friendliness, and it would be available on the interface, and users would be expected to do the same. They
Okay,
would
so
be expected to
it's
provide a default conversion type or defer to the built-in one we provide.
okay. So it wouldn't be, even if we had static dims, it wouldn't be dimmed because we can't. The compiler can't guarantee that can work. So
Right.
that would just be a convention. I guess the convention is you use whatever the appropriate default is.
Right,
And then
and-
you have a hook that somebody can specify one. So
Right.
okay.
And it's not as nice as I'd like it to be, but I think it's the simplest compromise between allowing you to, convert between an arbitrary T and U without having to necessarily support every type in the universe and the risks of throwing. It's the I support the core things that are important, and if you have another scenario that's important to you, you can do the quote unquote dependency injection to make it work. And specifically, this takes a T converter rather than an I number converter, so that generic specialization can kick in, so that you can implement this as a struct and make this converter call zero cost. Because generic specialization will kick in, the implementation will be in a struct, and inlining will occur.
Sure. So what effect does this have on all the words that only you understand? Like create saturating on a Tuesday with light showers.
Right. So effectively, the change would be in the create. In the create APIs, this would change from just T other to. It's not going to let me side by side this. It's going to change from just create T other to create T other comma T converter.
Well, you would have. I think you said you would have both here for the.
Right.
For create.
So you'd add on top of these the T other T converter overloads that.
Okay, so there would be create. The two create saturatings and the two create truncatings, not that there's a easily understandable notion of one that they can figure out how to do all those things in terms of the existing create.
Right. Okay. And we had actually previously said that we wanted create to be called. We wanted create checked, create saturating, and create truncating. We wanted to explicitly add checked on the first word. That was the note from design review of 205.
Okay. Yeah, I was gonna say I feel like usually when we say create with nothing else, that's kind of the how to go create yourself, go do it, and we don't often give those options, and then it's create from if it's from something else. But if we say create checked, then we've removed it from being empty.create.
Right.
So
there was previous feedback that maybe we wanted convert instead. There was then feedback that convert didn't flow as well, and it didn't make as much sense as create. Most people use a constructor here for their regular types, and so they want to continue using create for creating T's from other U's. So if no one has an objection here, the plan would be for me to finish fleshing this design out and then bring it back with the other decisions in like a month or so. But the plan would be for Preview 4 to ship with something that looks like this, to help mitigate the failure scenario.
Sounds good to me. The silence is deafening.
I like it. I like the extensibility angle being first class, using the extensibility approach to solve the problem within our own primitives. Makes that extensibility real.
And I imagine that there will be some users who hit this in at dev time, but now they at least have a workaround, and one that is not overtly complex to support or do. It also allows them to move the massive support of conversion code off to another type, to help simplify and organize their code.
Okay.
And the recommendation would be for struct converter, just like the recommendation is struct enumerators where perf is concerned.
Yeah, my only concern is that because this is the first time we use DIMs at a larger scale, that I don't know how how versioning will work out for us. Like, I mean, I wouldn't be shocked if we find some nasty corner cases with it that makes it very difficult for us to evolve this.
Yep, that's something that we're kind of going to have to live with and investigate, because the choice is either we use DIMs or we create I number 2, I number X, or whatever you want to call it, and continue doing that over time.
Yep.
So ideally, with the explicit documentation that we will add new APIs to these in the future, and the annotations that we've built up are around the explicit bad patterns, we will generally be in a good place to actually version these over time.
Yeah, I mean, the proof will, of course, be in the pudding, but because, as we've previously discussed, DIMs can't add new concepts without just being implemented as throw, and when we get to that point, we'll have to decide if that's worse than rolling a number on the interface. Because surprises always suck.
In technical terms, what would be the downside of using a version interface approach all up? It just means that in the generic code, people would not get access to new APIs unless they create overloads, right?
One of the problems is it's breaking to change generic constraints.
And you can't overload based on them, right?
Right, and so users then end up having to expose, some and some too as well, and you just get into a nightmare of names and everything else. And so the hope is that for the majority is that, one, we ideally won't need to add many APIs to these moving forward. The APIs that we've added and even plan to add are fairly well known. We're basically at parity with what other languages provide. And I expect the biggest thing will be future IEEE spec versions that may add additional functions that we need to expose for, IEEE correctness purposes. Outside of that, I expect there's a number of scenarios where we don't have to extend the interfaces. We can expose methods that take iNumber instead, for example, and provide a built-in operation. There's ways for us to provide extensibility without directly modifying the interfaces if that ends up being a requirement. And I expect many functions won't be applicable enough for us to say every number in the world needs to have this support. The few exceptions are things like maybe is even and is odd, where there's that's a pretty common operation that packages or libraries or runtimes provide. And so it's mostly a question of, do we expose it now, or do we decide, oh, we should have exposed it then a year from now?
Yeah, I think the problem is if we say the new APIs only show up in concrete types, that it kind of defeats the ability to write generic code over those, right?
So to return to a thing we glossed over, just so we can write down a decision. The all of these interfaces, except a few, are going to move to system numerics, right? Does anybody want to keep division operators in system? Cool. So let's move all the interfaces.
Is there anything left in system after this? Or is everything moved to system numerics?
The question would really be, do we want everything to be moved to numerics, or do we want system.inumber to be possible? I would guess that at a minimum, parsable and span parsable should be in system next to formatable. Equality operators, I think, would be fine in numerics if we said everything else moves to numerics. I think the same for number. I'd really be fine with people using system numerics more. Particularly since that's where the other number types are, that's where bit operations is, etc. There's I don't think it would be end of the world for system int32 to implement an interface from system numerics. Or for users to need to import system numerics if they want to use generic math in their constraints.
Yeah, I agree that the parsables should go with the formatables and just be in system. And then I can go either way with equality and comparison because we have the non-operator interfaces that they're affiliated with, but the rest of them I feel like putting them in numerics is better. So I'm yes, maybe, maybe, and then no for being in system.
Yeah, and I'd actually probably lean. I'd have I have the same overall view, but I would have a leaning of system, and then everything else numerics. I think equality operators and comparison operators make more sense next to the rest of the operator interfaces, even with equatable and comparable being in system.
Yeah, I tend to agree. I think the only reason why you I think suggested to put inumber in system was because I think there was an expectation that people can write relatively simple code where they're just constrained to an inumber and then they do some very simple stuff with them. That might be interesting, but I would also say if you start to learn these concepts, it makes sense to just say, hey, look at system numerics, and then you have everything, all the core concepts are in there. It's always weird when core types are somewhere else and they don't show up.
And if we really decide that it's popular enough even among beginners, and I hope it does, I hope that beginners start thinking about algorithms generically even when they start out, that the SDK could always start importing system numerics by default.
Okay,
as being CSI, etc.
Did we ever talk about the spelling of iParsable?
I believe so.
Because the formal English rule says there should not be an E in that word. Parse E-able is listed as the variant, aka people who don't know how to spell write it this way spelling.
The Wiktionary says the opposite. Wiktionary says the one with the E is the correct one, and the alternative spelling doesn't have the E.
Weird. I'm looking at Wiktionary, and it says that without the E is correct, and the alternative is with the E.
Interesting. I've always spelled and seen it spelled with an E. My general, intuitive way to write is if the word ends with E and has able, then it's E-able. Not dropping the E.
Well, actually, it says parse-able is alternative spelling of parsable. That's
in the one that I just linked?
That's the entire.
Because the one I just linked says has like here for the screenshot.
Parseable, alternative spelling of parsable.
Oh, I see.
Yeah.
I read that as an alternative spelling parsable.
No, and then it gives no definition because it says you should go look at parseable, P-A-R-S-able, instead
I
of...
don't have a strong preference, but I'm going to end up typoing this every time.
I didn't even think it, like, looking at it, it was fine, and then when I wrote it down, my fingers yelled at me of why did I just write EA. So apparently I learned enough in mandatory English classes that my brain says that this is spelled wrong. We can talk about that when we actually have quorum again.
Yeah. I don't have a strong preference. If we feel that the E should be dropped, then I'm fine with dropping the E. And if we want to go ahead and say that seems like the right thing, even just like with the few people here, then I'm fine with going ahead and making that change for preview 4, because we're wanting to try and get a lot of this ready kind of in the general shape for build.
Let's see if, I don't know, does Merriam-Webster have an opinion?
Yeah. It looks like the W3C explicitly drops the E. Verbs drop the silent final E except after C and G. So you'd have move-able with just an A, but change-able with an EA.
Yeah, because otherwise it's changable.
Yeah.
You need the E to soften the G, and we don't need it for the RS, so
since W3C says explicitly, like, there's a rule here only for C and G, I'd probably lean towards your initial judgment of drop the E is correct. And so I'd go ahead and do that for preview 4.
Okay. I mean, looking at them written down, they now both look wrong to me, which is true for any word if you look at it long enough.
Yeah. So I think we basically got through everything. Got all the great feedback. That was good. People were generally supportive of the splits and changes that the community had recommended. Community will still be mad at me about various things because can't make everybody happy. But I think we're in a generally good shape, and next time I come back, it will be reviewing the final surface area, ideally.
Yeah, I think the biggest outstanding issue that I see in my notes is figuring out what the naming pair is for the I number and the other one.
Yeah, and I'm probably just going to keep the main one I number because we said that was preferable. And I'll do more thinking on what iNumber base should be called, but I'll probably keep it as iNumber base in code for now. Because in the absolute worst case, that at least makes sense, and it clarifies it's the basis of other numbers, and it's because it's a base, it's the thing that you generally don't want.
Yeah, I agree. It's the more... I think we're probably better keeping iNumber as iNumber. And then if we think that no one's ever going to really write iNumber base except someone who wants to consume a complex and someone who wants to produce complex, then maybe base is okay. If we can come up with a better name, I think that'd be great. But
Yeah,
going with base for now and saying it's the one no one should write, so if that's where the breaking change occurs, then that's better.
Mm-hmm.
Is complex the only case that we don't have as comparable? Sorry, that we have as non-comparable?
It's the only built into the BCL case. There are a number of cases outside the BCL that are in similar veins where they want to support, for lack of a better word, more esoteric math, where numbers are not strictly comparable, and where they may have where they may not support some of the otherwise core concepts because they are effectively expressions, for lack of a better term. This is kind of what I was alluding to earlier, in that a complex number isn't really, it's a number in the mathematical sense, but in the programmatic sense, it's an expression.
Yeah, that makes sense. Yeah, I think I agree with the default sort of case being comparable, therefore naming the comparable one just number. I think that makes the most sense.
All right. Here, Tanner, let me take over the share just so you can see the notes I took and see if there's anything I missed.
I'll just drop the share there.
Share the screen. I think I'm sharing the correct screen. And then now I get to change this guy.
Bullet point 3 and 4 are
now out of date.
Yeah, we want to say that iNumber stays iNumber and iNumber base. We want to think about a different name if we can. I generally agree with Kathleen that I non-comparable is problematic in the same way that iList inheriting from iRead-only list would be problematic.
Well, I mean, if we could go back and do everything over, iList would extend iRead-only list, but
yeah, which is both correct and confusing.
I agree.
And in the same way, uncomparable being the base would make sense and be confusing. And if that's what we're willing to do, then I'm fine with that. But we'll have to finish that discussion next time. The fourth bullet point should be clamp, max, min. Basically the ones that rely on comparison. Yep. That looks good to me.
Yep, and this is also glossing over these points because I guess I can just copy and paste them at this point.
Yeah. At the very least, I understand the notes, and I'm probably the most important person to understand the notes since I'll be using them to make changes.
Yep. Okay, so with that said, to the 16 people who are still watching, and what am I even sharing over here? Oh, things are getting weird. Button. Who's got the button? Yes, I'm concerned with what the stream looks like as I sign off. Okay. My brain obviously has the right priorities. So we've got our notes. Is this a thing that says ready for review that I can toggle the state on? No. So I don't.
Yeah, it could be put at the bottom of 257. That's where I put it last time, was just at the bottom.
Yeah. Okay. I'm going to call this ready for review. And then I'm going to call it needs work. And this is because if we don't have a API dash label change during the meeting, then the mailbot won't send the thing out.
Right.
Okay. So, to the 3 people who have stayed on the call thus far, and the 16 people still watching on YouTube, jetzt es der Zeit Zoom Abendessen. No, Mittagessen. It's lunchtime. I declare that the meeting is over. I'm going to go eat. All right. Have a good afternoon, or whatever time it is wherever you are.